8:50 now, and I know that the quality of the evals I get from this talk will be strongly dependent on getting you out of here in time for lunch. I get that. I have a lot of code examples. This is going to be virtually all code examples. I have a few slides, and I have more code examples than we have time for. I have a workshop tomorrow with the same title, and anything we don't cover today is going to be in there, plus we're going to get opportunities to write a lot of this stuff. So you're essentially seeing the solutions, okay, to everything tomorrow, plus some other stuff, you know. Tomorrow it'll be very subject to the background and interests of whoever happens to be attending. We'll customize it that way, except for Puneet. Okay, so this talk is on Groovy and Java 8. So what I want to do is I want to show you some things that are part of Java 8, your lambdas, streams, method references, and I'd even like to show a couple examples from the java.time package, you know, giving some samples from that. And then I want to show the analogous things in Groovy, the ones that are very similar, plus some things that Java 8 does that Groovy doesn't, but that Groovy can still take advantage of because the full Java 8 API is still available to it. And then a handful of things that Groovy does that goes beyond anything in Java 8. AST transforms like memoize and tail recursive and all things like that. So that's the overall plan. We'll get started. Just some contact information. My name's Ken Kousen. It's Kousen like the relative, as I mentioned. So there's my company homepage, Twitter handle, email address, everything, and again, a link to the Groovy podcast, which we're going to try to do at lunchtime today. We'll see how that works out. You know. I've got a couple of books. The Making Java Groovy book is a Java Groovy integration book that was written before Java 8 came out. So there's nothing Java 8 related in there. The Gradle Recipes for Android book is very interesting if and only if you're interested in Android. You know, if you're a Gradle person, there's Gradle stuff in there, but really it's for Android developers. I also have a series of video courses at O'Reilly. These are on Safari as well. Some in Groovy, some in Android, some in Gradle. I've got a Spring Framework one and a, quote, advanced Java. See, if you just call it intermediate Java, nobody watches it apparently. So you have to say it's advanced, even though it's not. I actually have a new one out there called Java Generics, Understanding Generics in Java 8. Because if you've read through the Java 8 API, you know that they're using generics everywhere, and I needed a short one to talk about that. I should mention, by the way, I'm actually working on another book for O'Reilly that's going to be tentatively called Modern Java Recipes that will be all about Java 8 related functionality in practical mechanisms for in a recipe format for that. So that won't have any Groovy in it. So here we get the Groovy stuff. Now again, in this audience, I don't really need to define what Groovy is, but I did a presentation like this for Java 1 as well, back in San Francisco in I guess that's June or whatever. So they were unfamiliar with Groovy, so I just threw in a slide to say it's an OO language, etc. So moving on. So this is a brief list of the topics I do want to address. Lambdas and method references and streams, all from Java 8, all the functional programming stuff that was introduced into the language. And then the idea of map, filter, reduce being an idiom that we use in Java 8 on a regular basis, and then what's the analogous thing look like in Groovy. Of course, the other thing they've added in Java 8 is this whole set of collectors. The collectors class, which has ways to do toList and toMap and toCollection, joining, etc., but also has sorting mechanisms in it in these so-called downstream collectors, where you can get very easy mechanisms. I like to describe it as they went to a great deal of trouble to turn Java into SQL in many ways, even with group by and partitioning and everything. But then I'll talk a bit about those collectors and then things that Groovy has that go beyond any of this. Closure composition, for example, is something that Groovy's had from the beginning and not in Java 8. Well, kind of in Java 8, but not a lot. Closure currying, of course. And then AST transforms like memoize and trampoline and tail recursive and everything. I've got a fair number of tests. The tests are either in JUnit or Spock. I did both, just, again, appealing to multiple audiences. No problem mixing them all in, and I've got one Gradle build file for everything. So, of course, with Java 8, its biggest selling point was the addition of the functional programming mechanisms like Lambda expressions. And the biggest difference, by the way, is those of you who are comfortable with Groovy recognize, there is no class in Java 8 called Lambda. right? In Groovy, we have a class called closure, and we have methods in it and everything, and we can take advantage of them. But in Java 8, there's no class called Lambda. In fact, what they have are what they call single abstract method or functional interfaces. That's an interface with a single abstract method only. Now, you can also have static and default methods and interfaces in Java, which you couldn't have before, but you can only have one single abstract method, and then a Lambda can be assigned to one of those SAM interface types. So the typical ones in the new java.util package are things like consumer or predicate. These can be the target of a Lambda expression or a method reference, and the parameter types are all inferred from the methods and everything, and we're going to see a lot of that. But it's very different than the Groovy approach, because there is always a static type, and that type is an interface type. So there's no class called Lambda, and that has certain ramifications for all of this. So let me start off just by going directly to the code. Now this is in a GitHub repository, and I'll give you the link to that a little bit later. So starting right off here, I'm doing everything in IntelliJ IDEA, and I've got I did something I don't normally do, is I actually used a source main Groovy folder and a source main Java folder. Usually when I'm doing anything Groovy related and Java together, I put everything under source main Groovy. Let the Groovy compiler handle it all from there, and it does, that takes care of cross-compilation issues in general. Very helpful, but again, this was specifically to illustrate differences between Groovy and Java. So in general, I do have my code separated, but in a couple places I even violated that. Again, for this crowd, I should start off by showing you the Gradle build file. So I've got the Groovy plugin, and oh geez, this was generated, so there, I don't need that. The Groovy plugin, of course, includes the Java plugin. I did specifically set the source compatibility to 1.8, and I'm using JCenter for my downloads of the repositories. I'm using the latest Groovy. I also have Spock, which will bring in JUnit as a transitive dependency. And I think I did a couple of the extra additional handcrest matchers for things like big decimals, so that I could just do, the test could be a little bit more readable. But you see, there's nothing special there. I'm not using any major third-party libraries or anything like that. This is not reactive streams or anything like that, but this is all native functionality that's built right into both Groovy and Java. Now, the one I mentioned over here in the slides is this Lambda demo. So if I bring that up, here is an example in Java 8 of doing Lambda. So I just have a main method, and I created a list of strings. This is a list of strings. And if I want to print them out, then one of the things that's been added to Java 8 is a for each method. It's a default method now on iterable, actually, and collection implements iterable, and therefore I can do this on any collection, and that takes as an argument a reference of type consumer, one of the new Java 8 functional interfaces. And if I was in Java 7, even though I wouldn't have this available, but in principle I could implement this using an anonymous inner class, which about the best thing you could say about anonymous inner classes is eventually you get used to them. But otherwise, we'd like to avoid that, and then here's the equivalent Lambda expression. So that I'm invoking an accept method with my string argument and printing it. Here I can write that as a simple Lambda expression, and even, of course, as a method reference down here. This is the short form of the Lambda expression, the statement Lambda, as opposed to a block Lambda, where this has been expanded to have the braces in it and a data type on the argument and everything. This always strikes new Java 8 developers as surprising because they don't see a data type on the variable. For Groovy people, we're not surprised at all, but for Java 8 people, wait a minute, how does it know what it is? And I have to say, well, the for each method takes a consumer, and we're operating on an array list of strings, and therefore it's a consumer type string, and therefore the accept method takes an argument type string. The compiler's going through all this, and that's why you only have a single abstract method, so that it knows which method you are providing the implementation for. The Lambda expression or method reference is essentially the implementation of the single abstract method in the functional interface. Now, for those of you who've been doing Java 8 for a while, this is all familiar, but if you're not up to speed on it, I just thought I'd show you a quick example. You can also assign a method reference or a functional interface or a Lambda expression to a reference of this, SAM type, and then use it as an argument. You could use them as return types, whatever you like, all of that. Now, another one I want to show you is the map filter reduce approach. So here is map filter reduce in Java. So say I have my list of strings again. One of the biggest differences between the Java 8 approach and the Groovy approach is in Java 8, they did not add these relevant methods to collection. They have this intermediary, right? Every problem in computer science is solved by adding a layer of indirection, except the problem of too many layers of indirection, right? Although I think I could solve that with a layer of indirection. But at any rate, they invoke a stream method to convert from collections to streams, and that also lets them make it so that they're not modifying the original collection either. Because in Java, of course, the collections are not immutable by default, but streams in principle are, although there's some edge cases, but let's not worry about that. So this converts the streams to a stream, and then I can invoke a map method with my method reference to get the length on each one. That's actually mapping to integers, because the return type on length method is int. And then I can filter them by the even length ones. And now I want to turn them back into a collection. One of the things you'll discover when playing with Java 8 streams is that you cannot convert a stream of primitives directly into a list, because primitives don't support this mechanism. But if you invoke a method like boxed or map to object, then it turns them into capital I integer instances, and now I can convert them to a list, and there's that collectors class and everything. And this is a map. It's basically map, filter, oh sorry, here's the filter, reduce. Although reduce is a dicey term, normally when people say the word reduce, they mean to provide a single value from a collection or a process. In the Java 8 literature, they often use reduce to mean a single result, even if that result is a collection. So I'm going with the mushy definition there, but your mileage may vary. Now, on the other hand, well, let me show you the other Java examples, and then I'll go to the Groovy ones. Prime number checker I have as well. So here's the prime number checker in Java, and what I'm doing here is saying, all right, let's pretend we're in Java 7, for example. So this is isPrime method for an int in Java 7. So first I say if x is less than 2, I'm going to throw an illegal argument exception. Otherwise, if it's 2, then return true. Here's my limit, and I'll start at 2, and I'll go up to the limit, adding 1, and I'll divide by each of these indexes. And if it's modulo the index is 0, then it's not prime, or return false, otherwise return true. And you can tell, by the way, how the world has changed. This is IntelliJ IDEA. I'm already getting a highlight here saying, you know, you could do a none match with that, because it's thinking Java 8. But this is what you would do in Java 7. And in Java 7, a lot of the refactoring that goes from Java 7 to Java 8 is replacing iteration with transformation, with mappings, and replacing if statements with filters, etc. So here's the Java 8 approach. Again, I throw the exception. Again, I compute a limit. But I can just say return x equals 2, or I'll make a range closed from 2 to the limit. So that's inclusive as opposed to the range method. And I'll just invoke the none match method on that, and there you go. And suddenly it's a lot simpler. And there are methods like none match and any match and every match, all built into the Java 8 Stream API. And the Groovy people are comfortable with this approach because we've been doing this sort of thing for a long time. The Java 8 people are now becoming used to this functional approach. One meta comment, by the way. Why are we doing this? I mean, why all this move to functional programming, right? Why is that the hot idiom these days? And there are a lot of reasons, but the one that I always keep coming back to is concurrency. For a long time, Moore's Law was giving us such speed-ups that if you just waited, 2 years, 3 years, you get a doubling of the processor speed on your chips. And of course, Moore's Law was expressed in terms of packing transistors onto a chip, etc. Well, those improvements in speed have really tapered off as we start to hit speed of light limitations and things like that. So instead, the increase in performance is now coming from concurrency. I mean, heck, even my phone has 4 cores on it. I mean, who'd imagine that would happen? And when you're dealing with concurrency, synchronization is very, very difficult. The words shared mutable state drive functional programmers up a wall. They never want to have anything shared, because then trying to synchronize modifications is extremely difficult. So they want immutables with functions. And by the way, a lot of this comes from the mathematics literature, and despite seeming evidence to the contrary, mathematicians tend to be human also. And you can tell how they felt about a technology by the words they use around it. I mean, calling numbers imaginary, for example, they weren't happy about it either, you know, or irrational. They didn't like irrational numbers. Well, the phrase that's used in functional programming is a pure function. I mean, isn't that beautiful? What a value judgment being put on there. You know, it has no side effects. It does only what you supply and returns a value. But the benefit to these sorts of things is concurrency. Because now if you're dealing with pure functions with immutable objects, then simply adding more processors results in better performance as long as you manage the multi-threading and the context switching and all of that. And that's a lot of the motivation for what we're doing, for why we're moving to all this. It's because now we've got all these cores and all these processors, and we're trying to take advantage of it. Okay, one other I'll just show quickly is the streams demo, and then we'll look at some of the Groovy stuff. So here again, I have a list of strings, and with the stream API, I've got collectors like joining to join them all with a space or any other delimiter. I can map them to uppercase and join them that way. I can map them to ints using the length and add them up. I mean, there's your map filter reduce, except I don't even have a filter there. Here I can say, let's sum the first n big decimals, for example. So the stream class has the stream interface has a default method called iterate. This is big decimal.1. I have a static import for big decimal. And then I'm saying for each value, invoke the add method to add one, limit to some number that I'll supply, map them to doubles and sum. And I hate the idea of mapping them to doubles before I sum them, but unfortunately, there is no big decimal stream. You know what I mean? It's a double stream, an int stream, and long stream all have a sum method. The big decimal stream doesn't. What I really would do in practice is I'd use a reduce method, which I think I have down here. Now I did a reduce method with, again, going to sums, but I have other mechanisms as well down here where I say, okay, here's a reduce method, there's my accumulator, there's each value. I could print them out as I go by, and whatever I return on the accumulation here will be the result of the accumulator in the next iteration on that. So I have various mechanisms that we can use to do this. By the way, one of the other interesting things that happens in Java 8 is they've added a ton of methods to existing classes. For example, the random class now has an ints method, a doubles method, and a longs method to produce streams of random integers, longs, or doubles, respectively. So I can do that too. So again, if you're spending a lot of time in Java 8, there's all these kind of mechanisms available. Now I'd like to show some of the Groovy related approaches. So first things first, Groovy uses closures for what they call lambdas. Now technically, and this is something you could debate, but let me just give you the base definition. The difference between a closure and a lambda is a closure includes the execution environment as part of it. They say it's a function that is closed over the environment that it's within. And this is a problem if your first exposure to this stuff is JavaScript. Right? Because then you're constantly wrapping functions inside of functions. It's not really an object-oriented language at all. It's an object-based language, and it's very hard to keep track of where this variable is pointing. You know, what's in scope at any given moment is a debugging challenge in JavaScript. Groovy and Java are strongly typed languages. I don't mean statically typed. I mean you always have a class. You always know where you are. So it's actually much, much simpler in Groovy and Java than it is in JavaScript because you can always tell what's in scope at any given moment. So a closure includes the execution environment, and wait a minute, Java lambdas include the execution environment, so Java lambdas are closures. Okay, but again, we'll let them go, I don't care, you know. But in Groovy, we have a class called closure. We actually use that name. So in Java 8, of course, the stream methods are in Java 8, they use the stream metaphor to add all the methods. In Groovy, these methods are added directly to collections through metaprogramming. So methods like collect and find all and inject are used instead of map, filter, and reduce, and these are all directly done right on collections. Now this is good and bad. There's a benefit, and there are costs to this as well. So if I look, for example, at my basic example here, now, if you are trying to invoke the Java 8 API, as I'm doing in this particular top example, then anywhere where the Java 8 API says it wants a functional interface, where it wants a lambda or a method reference, you could just provide a Groovy closure. Now, right now, Groovy does not support the Java 8 lambda or method reference syntax, but we can provide closures and they work. Now, That will change, by the way. I expect this year, by the end of this year, in Groovy 3, they are planning to provide the support for the Java 8 syntax, but we're not there yet, and it's not really a problem. So here I'm invoking the stream method on an array list, and the map method takes a lambda. In fact, it takes a function, java.util.function.F function interface, one element in, one element out. Here I'm providing a closure that doubles the element. Here's the filter method, takes a predicate. I'm saying return the elements that are evenly divisible by 3, and then there's my for each, there's my print mechanism, and this is a real blend of Groovy and Java 8. But really all it is, it's a Groovy script that's using the Java 8 API and just substituting in lambdas where necessary. See, now this is even closer to what Java 8 would look like. See, the generate method, for example, says provide a supplier, which is a lambda that takes no arguments and produces a single value. So I'm using math : random. But because Groovy doesn't support that syntax, I can use the .ampersand syntax, which I never use in Groovy. But I can, and this would work. The alternative would simply to be put in a closure that's math.random. Just invoke the random method. But if you just want to see it, there's the method reference syntax in Groovy. Again, I put on a limit. I can map to int. The cast was not necessary. It was only to make the IDE happy. And then filter, and then of course my summary statistics method is a beautiful method, returns a double summary statistics, or in this case an int summary statistics, that shows the count, the sum, the min, the average, the max, all built directly into the Java 8 Stream API. So this is basically Java 8 code written in Groovy, if you will. Okay, so the next one I want to show is that map, filter, reduce approach. So, there, map, filter, reduce in Groovy. So again, in Java 8, there's collect, find all, and sum, map, filter, and reduce. So here I threw in a list of cities. And as an American, my geography is really good for an American. But what that means is I can put India on a map, you know that for most Americans, that's a high bar, I mean, but I've been practicing this, and you need help me out here. So, okay, so I could say Bangalore, that's easy. Okay, Mumbai. I could say, I've learned to say Chennai rather than Chennai, right? Chennai, right? Pardon me? Chini, you're right. And then this is the one I've been practicing. Hyderabad? Is that close?
Yeah.
Yeah, okay, you say it.
Hyderabad?
Yeah, see, every Indian I know does this. They all say, yeah, great, and then they say it back and it's different. They're all being nice to me, I think they're sufficiently surprised that Americans are actually making an effort, that, At any rate, there you go. So I've got my cities in here, and then this again is a map, filter, reduce. I'm using collect in Groovy, which is kind of unfortunate because Java 8 has a method called collect on streams. But this is collect that takes a closure as opposed to collect that takes an instance of the collector interface. So I provide my lambda here, or my closure, mapping to uppercase, and then I can do a sort, and with false here I'm saying I want a new stream, so that it's not, I want no mutable state here. And then I can join with a comma space, and I wind up getting my cities again this way. So this is sorted as well, so I could put in the assert. If I didn't sort them, I wouldn't be 100% sure I get the right order out of it. Again, here I can do a collect and a sort and a join. So this is the sort of functional programming in Groovy that we're used to. We've been doing for years, but it's compatible with the Java 8 approach. Okay. Let me show you the analogous prime checker as well. And this is the one in Groovy. So here I say is prime, and it says if x is less than 0, throw an illegal argument exception. And then you just set your limit here, and I return, and of course I don't even need the return keyword, right? X equals 2, or from, let's see, 2.limit.find, and there's our built-in find method on collection, and find the first element that satisfies the closure. And of course I'm taking advantage of the Groovy truth by saying not that, which therefore returns the Boolean if there's none there. And thanks to Tim Yates, by the way, for this idea, because I kept trying to write it more complicated. He said, no, you can simplify. Tim Yates is the guy to ask for anything like that. Very, very good on that sort of thing. And you see how simple it is, and this goes beyond what they have in Java 8. They don't have the built-in finder approaches. They have analogous things, but this is very, very simple to do in Groovy. I know I'm going to run short on time, but let me give you the prime number joke anyway, just because I like the prime number joke. One is a math test, a one-question math test. Prove or disprove that all the odd numbers are prime, right? And the mathematician goes, well, 3 is prime and 5 is prime, therefore by induction all odd numbers are prime. The more math you know, the funnier that one is. The physicist goes, 3 is prime, 5 is prime, 7 is prime, oh, 9. Well, it could be experimental error. 11 is prime, 13 is prime, yeah, that's got to be enough. Right? And the engineer goes, 3 is prime, 5 is prime, 7 is prime, 9 is prime, 11 is prime. And the computer scientist goes, 3 is prime, 5 is prime, 5 is prime, 5 is prime, 5 is prime. And the manager, or change it to whatever you want, 2 is prime, 4 is prime, 6 is prime. Okay, so at any rate, see, more value added for you coming to the talk today. Okay, so there's your prime number approach as well. Now, one of the things that Java 8 has that Groovy does not, one of the advantages to going to streams is the ability to make the streams lazy. They only process as much data as is required. So if you're looking for the first value with a find first, you can make sure that you're only processing as much as needed. Whereas the collections in Groovy are not lazy. But of course, Groovy can use Java 8 streams if you want to. So for example, here is the lazy streams in Java. Is that I can say here, let me look at it down here. Let me find the first even divisible by 3 between 100 and 200, just to pick a random example, which I stole from, reused from Venkat Subramaniam, with permission, but nevertheless. So I've got a range here from 100 to 199, and I map them to their doubles, and then I filter by the ones divisible by 3, and then I want the first one. Now find first is going to return an optional, so I invoke or else to say if I don't find anything, just return 0, So the problem with this, of course, looks like, to someone new to this, it looks like I created 100 numbers, and I doubled them all, and then I did 100 divisions on them, and then I only wanted the first one. And it's like, wow, that was a lot of wasted work. Now what I can do is I can make this verbose. So this is the verbose approach, and notice that here now I've got method references instead of the lambdas, because up here I turn them into methods. Multiply by 2 now says, hey, I'm inside multiply by 2 with this argument, and then multiply by 2. The same thing on divide by 3 with divide by 3, so that this way I can actually see the values being exercised as they go by. And I have a test case here, which is a Spock spec. There's my lazy streams right here. And if I did just the first even divisible by 3, then of course you're going to see that I just have the output. I don't have, this is not the one that's verbose. So it just prints out the number. Hey, I ran it on the whole thing. Well, what the heck? Here you can see in the Java one, hopefully that's visible, then you're going for 100 multiplied by 2 is 200. Is it divisible by 3? No. So we go to 101. And then we double it. And then we see if it's divisible by 3. And is it divisible by 3? No. So we go to 102 and double to 204. Is that divisible by 3? Yes. And we're done. And therefore, all we did was process 1, 2, 3 of the numbers of the original stream with as few calculations as necessary. Now, in the Groovy approach, I did it on the actual collection. So here I say first even divisible by 3, do a collect and a find, and you can see that with Groovy, I'm going through every single value all the way up. And then there's the answer. That's the one that satisfied it. And that can be annoying, except for the fact that, first of all, there's the verbose one. That's what's showing down here. Here I can say, you know what? Let's just use the streams from Java. No harm done. So I changed it to a range closed, and a map, and a filter, and a find first. And now I'm using lazy streams. I just happen to be writing the code in Groovy. So you're free to mix them, and if you ever have something that lazy streams is an advantage, because it's not always, if you're going to do a sort, or you're going to do a sum, or something like that, there's no advantage. But if you are doing something where a lazy stream is an advantage, then just use the Java 8 stream code in Groovy. No harm done. Okay, and let me move on, of course, to POJOs versus POGOs. In fact, in this one, given the time frame and the fact that you're all reasonably comfortable with Groovy, let me just say that POGOs are a great advantage, and use the canonical AST transform, and you get all the extra methods, and it can be used anywhere where you need a POJO. So what I will show is the sorting mechanism. So here, for example, in my sorting one, I have a golfer class in Java, implements comparable first name, last name, and a score. I've got a couple of constructors, or multiple constructors. There's my compare to method. I'll sort them by default. The natural ordering will be on score. And then I have getters and setters, and an equals method, and a hash code method, and a toString method. And it took me 77 lines of code just to wrap a couple of attributes, you know. And it's a pain, right? Except for the fact that at least in Java, they have made it easier to do the sorting. So here's my collection of golfers. I've got Nicholas and Tiger Woods and Tom Watson and Ty Webb and Bubba Watson. So I've got Tom and Bubba both have the same last name, so I can sort based on that. And then Ty Webb, anybody? No? Caddyshack? Right? So, and multiple scores. I mean, if you haven't seen Caddyshack, you have a real treat in front of you, but one of the most quotable movies of all time. It was Chevy Chase, and moving on. But now I can do, in Java 8, I can say make it into a stream and invoke the sorted method, which produces a new stream that's already sorted, and then I can print them out. But we also have these comparator mechanisms now. So I could say sorted by comparator.comparing int on the score, then comparing on get last. And while I could write the comparisons myself for a single property, when you start to do multiple comparisons, life gets a little bit more complicated. Now this is part of the Java 8 API. In fact, here I can sort by score, then by last name. So equal scores sort by last name, equal scores and last name by first name. And it works like a charm. You know, it works very nicely. This is what I mean by partly turning Java into SQL. You know, they built all this into it. Now, there's also even things like partitioning by and grouping by. Here I can partition by all the scores below 70 and the scores above 70 or equal to and greater than 70. And that will give me a map of Booleans to a list of golfers. And there's a for each method on map that lets you print out the keys and the values that way too. And I've got a test case and everything. Now, of course, in Groovy, what I would do instead, in many cases, is I would simply add sortable AST transform. Now, this is assuming the domain class is something I can edit. You know, if it was a library class, then I would use a similar approach to what I just did. But the AST transform lets me specify what to sort by in what order. So sort by score, then equal scores by last, equal last by first. I just threw in a toString method of my own, and now I can do all the sorting there as well. So, for example, in Groovy, here again is my collection of golfers using the map-based constructor. The sorted AST transform provides a toSorted method, among other things, and then I can check the lowest score and the last name of the first one and the first name of the last one and print them all out and all this information. And this all comes from Groovy, from that one AST transform. So yeah, okay, Java 8 improved their situation by a lot, but we still have it on them. You know, it's still a lot better and easier this way, but not a bad thing. Let's see. I also have one other thing here. If you don't want to use the sorted AST transform, or there's the default, the natural sort, you can also provide your own closure to the sort method. So this takes the same syntax as a comparator. So take each, string here. So here I'm sorting strings, actually. This is a list of strings, and I split them up. And I say for each pair, just return, there's my, whoa, looks like oh no, it's the font. Okay, never mind. I'm using this cool looking font, and it messes things up sometimes. At any rate, this is returning the comparator. But of course, in Groovy, you have the closure that takes a single argument rather than two for the sort method, and then you're just sorting by an individual property, and it'll sort by that property and then sort the strings that way. And you can even do, there's my alphabetical sort and then natural sort that even uses the Elvis operator. So this is basically sort by size, and then equal sizes, which return 0, sort by alphabetical, lexicographical, to be honest, okay? Or if I want to make the joke out of it, this shows that we have Elvis here being carried back to his home planet by 2 tandem spaceships. See? So it's the fat Elvis from the 70s and not the thin Elvis from the 50s. All right, it's not that funny. Look, I mean, there are, what do they say? A comic says funny things, and a comedian says things funny, right? And on that scale, that makes me a software developer. So moving on. And they can't all be gold here. Okay, now, I'm going to skip the geocoder. I showed a little bit out of that. Now, what can we do to go beyond what Java provides? Because all the things I was showing work either with Java or as alternatives to the Java mechanism. But it's the same as, like, many of you know Scott Davis, a friend of mine. He likes to say that Groovy is Java, except that Groovy is not Java. I mean, he says stuff like that, you know. And so far, I've shown you things that you could do in Java. It just would take different code and usually more code. But there are things that Groovy can do that go beyond it. And I want to show, for example, memoize and tail recursive. So if I look here at my annotated functions. So here I have your standard Fibonacci calculation, where I take a number, and I'm going to use big integers for this. If the number is 0, return 0. If it's 1, return 1. Else do the recursive calculation. As the joke goes, this year's Fibonacci conference is going to be as good as the last two combined, right? Yeah. Any rate, so this is calling fib of n-1 and adding in fib -2, which is just begging for memory, stack overflow, right? You're just going to run out of memory very quickly. However, if you throw memoized on this, then that automatically builds the cache of previously invoked mechanisms. So every time I call fib with a particular value, that becomes the key inside the cache, and whatever it returns becomes the value inside the cache, and I didn't have to write the cache myself. All I did is there's a memoized method, or in this case I use the memoized AST transform, and it gets applied automatically. I don't have to do anything, and now all the previously calculated values will be stored in a cache in memory, and now I can do Fibonacci to, well, almost arbitrarily large values, because I'm not multiplying the number of calculations arbitrarily. So here's my test on this thing, and if I just say, okay, and you have a Spock test here, here's n and here's Fibonacci of n, and I could run through those very quickly, but with memoize in it, when I call this, you can see I could do these, and it becomes very, very fast. And then to show the factorial one as well, see here's the factorial, again, expressed as a recursive calculation. If n is less than 2, return a 1, else return n times fact of n minus 1. Now with the memoized AST transform on there, I can do factorials up to here, or I can really go nuts. I think I have some others too, that calculate extremely high values that I'm going to demonstrate. But let me show what else is in this class before I do that. Now, I wanted to show also, I wanted to demonstrate that we could do a sleep here as a way to demonstrate what memoize is doing. So, for example, I want to add the two numbers together, but the difference is that I'm going to sleep for a second and then add them. So there's my add method now, so that without the memoize, I'll get the sleep for a second, and with it, of course, it'll just come back instantaneously. And I think I have it on the sum up method here. Well, I'm doing the tail recursive stuff, so I'm showing several things at once. So let me show a couple things, and then I'll run the test. So first thing to show, with tail recursive, you make the last call to be a recursive call with the same arguments, but a modified arguments. One is the accumulator, one is the new argument being modified in some way. So this factorial says if n is less than 2, return the accumulator, else call factorial on n minus 1, and then use the argument as n times the accumulator. See, so there's no shared intermediate state here, there's no shared modifiable state, it's all arguments to the method. And this, when I throw on tail recursive on it, does the same advantages. Now, by the way, this is another feature of Groovy that Java doesn't have, is the fact you can initialize arguments. So by putting in accumulator equals 1, I can start it right there, and I don't have to worry about starting on the wrong value. Also, inside the Groovy docs, there is an example of greatest common denominator using tail recursive, and here's a sum and everything. And I just want to show the test here so that I can move on. And you see all the tests pass, but I also have a class called use the annotated functions to give it a little bit clearer picture here. So this one, I want to time it. So what I'm doing is for each number from 1 to 100, now by the way, this is Java code that's going to call a Groovy code. because why not, right? The easiest way to integrate Java and Groovy is put the Groovy code in a class, have the Java class instantiate it, and just invoke the methods like they were any normal thing, you know? So here I'm going to time it. So I'm going to say for each number, let's call nanotime before and after. Let's call Fibonacci with a big integer with that value, and then print out the value and the time, okay? And then I'm going to call that add method 3 times with the same arguments, and then here I'm going to do the same thing with factorial, and then I'm even going to do factorial of 70,000, which would massively overflow if I wasn't doing it in the memoized approach. So when I run this, you'll see that here were the initial numbers, you know, moving up higher and higher and higher. The times are all extremely fast. So there I'm up to 99, and it's still not taking any time to do the calculation. There's the add method coming back. The one delay we saw was the 1 second delay to do the first add, and then these were instantaneous. Here's factorials. Again, the time is almost too small to measure, and I can go, I mean, look how high that's going, way, way up. And in fact, 70,000 factorial has 308,760 digits or something like that in it. And this is all for free just by using @memoized or @tail recursive. Built right into the language. Very, very helpful, and something that most Java developers are completely unaware of. Now, the other thing I wanted to mention is that in Groovy, we do have closure currying. So here's my add closure, if you will, and you're aware that the closure class has a call method in it, and I can do that, or I can just use the closure as though it was a method and invoke it that way, of course, without putting data types. Then I'm able to use this with strings or dates and integers, whatever I like. So here it is with a date and an add with a date and an integer, and that works too. And how about this one? This is cute. ... meaning 0 or more values of untyped type. You know, I'm not specifying a data type, just 0 or more of them. And this is saying do add all is to take all of those and to invoke the sum method on it. So the only key here is that they are methods that do have the ability to add. So here I'm able to add 3 numbers or 2 letters, however you want. Also, I can do multiplication this way. And here's the currying mechanism. So when I call curry, I'm taking a function and supplying an argument and getting back a new function that replaces that first left-hand side argument with the value I supplied. So if add took 2 arguments, add 3 just takes 1. So it always adds a number to 3. So add 3 of 4 is 7. Or times 2, you could do an R curry to curry from the right side instead. There's also an N curry, but that's dicey because if you do any refactoring, that could mess that up. So the left curry, the right curry, you know. And by the way, isn't that the greatest resume of all time? Haskell curry, right? I mean, if your first name is a definitive functional programming language and your last name is a technique in that language, well, you win, right? I mean, that's the perfect one. The second best resume of all time in computer science is probably Sir Timothy Berners-Lee, right? If your work gets you a knighthood, you know, okay, that's a success as well. So at any rate, there's a handful of those. But Haskell curry, oh my goodness, you know. So Groovy has currying built in, and we also have composition using a left shift operator or a right shift operator, where you can apply closures together and build up a composed function. These are these higher order functions that the functional people really like. So I'll just mention this, and maybe we'll look at it more tomorrow, just as an example. I know I'm running out of time, so I just want to show a couple other examples. Okay, well, one thing with the metaprogramming, yeah, okay. This is great on International Talk Like a Pirate Day. So here is pirate.groovy. Is that what I did? Is I said, let's take the string class and add a method called pirate. And there is a website called, hackday.com, rpi.php, believe it or not. And you supply text, and it will return that text in pirate speak, argmates and all that kind of stuff. So I'm adding this as a method to the string class so that now I can go hello world.pirate or how are you or please fill out your session evals. And again, Tim Yates is the one who suggested this particular website as an example, and then you can see if it comes back, come on, you can do it. Oh, did I run out of, it worked before. I'm losing my internet access or something, I have to restart that. But at any rate, the mechanism does work, and you're able to add simple metaprogramming to Groovy and get functionality that way. One last thing here, by the way. This is one of the scariest pictures you can ever show a developer. This is the set of time zones in Antarctica. I mean, can you imagine? I mean, look at that. Isn't that awful? But that's not the worst part of it all. You see the South Pole here? It's in this hash region. This is called the Ross dependency. What the hash region means, and this is amazing, is that the South Pole, a place where it's 6 months of daylight, 6 months of darkness, is on daylight savings time. Amazing. And it's because the Ross dependency is managed by New Zealand, and New Zealand uses daylight savings time, and therefore you get that. Well, it turns out in Java 8, of course, we have the date and time package, and therefore we can do something like this. I can do all the available zone IDs and find all the ones with Antarctica in it, and I'll take the current time and put that zone ID on it, get the offset, and print them, and this way you can see there are all the time zones in Antarctica sorted that way. Again, just using the Java 8 API in a way like that. The last one I'll show here, by the way, came up when I was telling people I was going to India, because of course Indian Standard Time is on the half hour, right? Which most Americans are like, wait, what? I didn't know that was possible. And by the way, as you know, if you studied any of this date time API, there is no Indian Standard Time, there is no Eastern Standard Time. It's all region IDs now, which are either UTC offsets or they are strings. So here what I have is a mechanism to look for all the offsets that are not integers. Okay, so this one I get an instant and I find out the instant at that time zone, and then I stream all the zone IDs. This is the Java approach. I have a Groovy one as well. Map them to zone IDs, filter them by this mechanism where I get the offset and look for ones where the total seconds is not evenly divisible by an hour. Okay, by 3600. And then I sort them using the total seconds and then print them out. And what you find out here is here are all the time zones that are not by an hour. And not only are there some half-hour ones, Kathmandu is 45 minutes no less, as is Chatham in the Pacific in New Zealand, and Australia, Eucla, which I had to look up. It's like 600 population 600. Old railway station, I think it's even abandoned. Go figure. Ask Paul King about that one. But at any rate, I can do that in Java, or I can do that in Groovy as well. And I think, oh, this is a different one. I'm sorry. Here, this is the Groovy one. And again, you see I've got to find all, a collect, a sort, and an each. And the Groovy code still looks simpler than the Java code. That's just the one on the time zones. And just, that's enough. I just want to give you an idea of what sorts of things you can do. So, we don't have time for the cat pictures. That's your teaser for tomorrow. Or access Flickr. It's a RESTful API and generate pictures of cats. I mean, that's what the internet was created for, right? So that's in there too. I even do that using parallel streams as well. So we'll do that tomorrow. So in summary, you use Groovy and Java together. That's the expected normal idiom in Groovy. It's not like Scala or Clojure or even Kotlin, where Java is used as a library. Well, Kotlin has more of an integration, but Scala or Clojure, where they expect it as just a jar file, and everything else is pure language. In Groovy, you can modify on a line-by-line, method-by-method, well, class-by-class basis. Mix the two together and use Java for what it does well, or as I like to say, Java is good for tools and libraries and basic infrastructure like Spring and Hibernate, and Groovy's good for everything else. So here you have these capabilities. Everything is in the GitHub repo at my last name / Groovy_Java_8. You're welcome to all that, and I did go a little over. I'm sorry about that, but I'll hang out if there are any questions. Otherwise, thank you very much for coming.